All right, you have seen how to draw the mechanism of an imine formation. Okay, now here's the property of an imine formation. Okay, the imine reaction is very pH dependent. Okay, which means that changing pH affect the rate, okay, greatly. Okay, from experimentally, imine formation has the fastest rate at slightly acidic condition, about 5, 4.5, 4-ish around here on this area. Okay, too high pH, slow reaction. Too low pH, slow reaction. Here's the reason why. Okay, all right, try to think with me. At high pH, what species dominate at high pH? Well, let's do this. What do you have to do to get to high pH? Base. Can you imagine a bunch of hydroxide ion floating around in solution at high pH? Right, pH like 10, 11, 12, 13, a bunch of OH ion, hydroxide ion floating around. Okay. Now, if we have too much of hydroxide ion, well, it's a base, right? The depronation. Okay. Which steps in this mechanism that we just drew, okay, which step becomes slower? Well, too many hydroxide ions, any acid, any step that involved in acid will become slow because we don't have a lot of the pronation right there. Okay, so the proton transfer will become a rate determining step. Right, that's the reason why at high pH this reaction is slow. Now at low pH this reaction also slow too. Well, low pH, think about it. Like you have a bunch of the hydronium ion floating around, add a bunch of acid into this solution. Okay, which step gets slowed down? Well, anything that involve the proton abstraction, okay, the depronation, basically, all right. But so this step, this one of them, okay, anything you see right here, pretty much correct. But this step here, if there are a bunch of hydronium ion in this solution, we won't have a lot of nucleophile available for a nucleophilic attack. Okay, of course you can say too the depronation should be slower, but nucleophilic attack compete with depronation. Okay, nucleophilic attack is gonna be much slower. This is proton transfer, usually the fastest reaction in the world. All right, this is gonna be slower anyway, so we're gonna focus on just this guy. Anyway, we don't have a lot of this nucleophile available, which means that this nucleophilic attack gonna be slow. Okay. All right, that's pretty much it. That's what I have to talk about. So this reaction is pH dependent. Okay, slightly acidic. That has the fastest rate. Okay. Let's try draw on your own. Would you? This one we have an aldehyde and we have amines in the same molecule. Okay, this one primary amine. Show the structure of imine first, and then draw the mechanism to explain how it forms. All right.